So this class we are going to discuss about how to convert a delta connected resistor configuration to star connected and star connected to vice versa. So here we can see that a delta connected resistor configuration with a 10 ohm, 60 ohm and 30 ohm resistors, and we are going to find its equivalent star connected resistors. So we already studied the formula for converting the delta to star connected resistor network. Let's see that. Here see that the star connected configuration is put inside the delta connected. So now it is very easy to find out what is RA, RB and RC. Let's see what is RA. RA is, you can see that the resistors that comes very close to the RA, that is a 10 ohm and 60 ohm. You just multiply this 10 and 60, which is divided by, and add all these three resistors, that is 10 plus 60 plus 30. So this is 600 divided by 10 plus 70 plus 30, 100. So 600 divided by 100 is 6 ohm. Then in the similar way, let's see that what is RB. So RB is equal to, so what are the resistors that is near to the RB? There is 60 ohm and 30 ohm. Let's multiply 60 and 30, and the same denominator, 10 plus 60 plus 30. So this is equal to 1800 divided by 100. So 80 ohm. Let's see that what is the value of RC. So when you take RC, we need to consider 10 ohm and 30 ohm. So these are the amps of resistor that is neighbor to the RC. So 10 ohm and 30 ohm. So let's multiply 10 and 30. That is on the numerator side, and same the denominator side, that is 10 plus 60 plus 30, which is the sum of all resistors. So this comes around 300 divided by 100. So this is 3 ohm. So when you convert this star connected network to delta connected network to star, you got the answer 6 ohm, 8 ohm, 18 ohm and 3 ohm. So these values are, so they are 6 ohm, 18 ohm and 3 ohm. And let's use the same values to convert this star to delta, and let's see that whether we get the same answer. Again we are going to do the reverse process. Now we have the star configuration, its values are known, and we are going to find the equivalent delta connection. And let's see that how to find the delta 1 values, R1 and R2 and R3. Let's find R1. So R1 equal to, first you have to multiply 6 ohm and 18 ohm, 18 ohm and 3 ohm, and 3 ohm and 6 ohm, and add all together. Let's multiply 6 18 plus 18 3 plus 6 into 3, 6 into 18 plus 18 plus 3 plus 3 plus 3 into 6, that is divided by let us see from the perspective of R1. The resistor which is one opposite to R1 is 18 ohm. Look at from this R1 side, you can see that 18 ohm is opposite to R1. So let's take numerator 18. So when you multiply all these three and add together, so we get 180. So 180 divided by 18 is 10 ohm. And let's take R2, the same numerator, that is 180, all divided by, look, from this side if you see, you can see that the resistor that is opposite to R2 is 3 ohm. So 180 divided by 3 is 60 ohm. So likewise, what would be the value of R3? The same numerator value, that is 180. How do we get 180? By multiplying 6 times 18 plus 18 times 3 plus 6 times 3 divided by, let's look from R3. What is the resistor that is just opposite to R3? That is 6 ohm. So 180 divided by 30 ohm. So value of R1, R2 and R3 are, R1 is 10 ohm and R2 is 60 ohm and R3 is 30 ohm. Let's compare it with our question. So R1 is 10 ohm, R2 60 ohm and R3 30 ohms. So this is a very simple way of finding out the value of the delta when the resistors are connected in delta configuration or star configuration.